All right. Well, welcome everyone. Good to see you all. Thank you so much for joining our webinar tonight, sponsored by the City of Eden Prairie. We'll be talking about Electrify Everything Minnesota and the what, why, and how of home electrification. So tonight we will be going over what is electrification, why are we talking about this, and then we'll go into the key pillars of electrifying a home. So that's weatherization, the heating system, and then appliances. Then we'll talk about how to get electrification ready, what you might need to do to your house first, and then all of the resources that are available to help. Then we'll have a Q&A at the end, and would love for folks to come off mute at the end and ask their questions live. I also encourage everyone to put your questions in the chat as we go. I know for me, sometimes like the question pops up and I need to write it down, so throw it in the chat and it'll help me understand what we're going to talk about in the Q&A time. Okay, let's get into it. So, what is electrification? Why are we talking about this? At its base, electrification is replacing fossil gas or natural gas equipment and appliances with electrically powered options. And we're going to spend today talking about what that means. First, some quick background on the Electrify Everything Minnesota program. This program aims to support the gradual electrification of single-family homes to promote resident health and climate sustainability. And gradual is a key word there. It's really a step-by-step process. We don't expect anyone to fully electrify their house all at once. So we really want you to find what's that first project that you want to tackle. And Electrify Everything is managed by the Center for Energy and Environment, where I work, and is supported by the local governments of Eden Prairie, Edina, Minneapolis, St. Louis Park, Hennepin County, and Foundation partners. And I'm realizing I didn't introduce myself. My name is Matthew Douglas May. I'm an assistant program manager at the Center for Energy and Environment. All right. So, why are we talking about electrification? There are a lot of reasons why this is a really hot topic right now. But one of the big ones is that there are a lot of opportunities for clean electricity right now. So the state of Minnesota passed a law last year that will require all electricity in the state to be carbon-free by 2040. So when you switch from natural gas to electric appliances, you're joining that timeline of being carbon-free by 2040. There are also lots of options for getting 100% renewable energy right now. Electricity is also safer. A lot of gas appliances like stoves and natural draft water heaters leak hazardous gases back into the house, and those can have really adverse effects on our health. So when we switch to electric, we completely eliminate those health risks. Another reason is that electricity rates are more stable. So the Public Utilities Commission of Minnesota regulates electric rate increases, so they're a lot more predictable and incremental, whereas natural gas is bought on the open market, so there can be really big spikes and valleys over the years, and it's harder to predict. And then another big one, which draws a lot of us to this topic, is that electrifying your home is one of the single biggest things you can do to reduce your carbon emissions and help the planet. So if you're motivated by helping the environment, this is a really powerful concrete action you can take. So there's a lot of good reasons to electrify, and it can feel complicated and overwhelming at first. There are a lot of questions that come up, like how do I decide which projects to pursue first? What does my house even need? What are the types of equipment I should be looking at? How do I compare one to the other? What are the resources and how do I make sure I get all the incentives that are available? And then who are the contractors I should talk to? What could I do myself? who is going to actually install this in my home? So there's a lot of questions, and the goal of our program is to have answers to all those questions in one place. And like I said earlier, we encourage you to start with where you're motivated and what makes sense for your house. So maybe your water heater is really old and that's where you need to start. Or maybe you really want to reduce your carbon emissions. So we're going to talk about, what's the biggest carbon emission impact. Or maybe you just, want to do what's the smallest, cheapest step first, and we'll, work our way up. So really, whatever approach you're bringing to this, we want to meet you there and help you start that project. So the key pieces of a typical home for electrification are weatherization, heating, water heating, clothes drying, and cooking. So I'm going to go through each of these one by one, starting with weatherization. And again, throw any questions you have in the chat and we'll get to them at our Q&A session at the end. So what is weatherization? Weatherization refers to the part of your home that keeps the outside out and your inside conditioned air inside. So that's the insulation in the walls in the attic, that's air sealing, all the cracks, and then it's also your windows and doors. So what's the barrier between the inside and the outside? The reason we start with weatherization is that it's really important for electrifying your heating system, and I'll dive into why that is. But there are a lot of good reasons to insulate and air seal your home. And I think I was surprised by this when I first learned this, and a lot of people are. We live in Minnesota, it's super cold, and yet a lot of our houses do not have proper insulation and air sealing. The reason for that is before 1980, there was not an energy code that required insulation to be put in houses. So homes built before that time often don't have any or lack adequate insulation. But it's a really great first step to take. So on average in Minnesota, you can cut your heating and cooling bills by 18% by insulating and air sealing. That's a significant amount of money and energy. It's also really cost effective. You're reducing how much energy you need to keep your home comfortable. So you're lowering your energy bills, and that will pay for the insulation, usually in 7 to 12 years. It also improves comfort. We've all been in cold, drafty homes that are not super great to be in. So it really is a big quality of life improvement. You can prevent ice dams, those big icicles. And then, as I mentioned, it sets up the home for electrification. We all, can picture insulation. It's the pink stuff or the white fluffy stuff. But air sealing is kind of the less acknowledged partner of insulation, and it's super important. So air sealing is sealing up all the cracks in a home where your conditioned air can escape. So that's like around light fixtures, your attic hatch, your bathroom fan, any venting pipes that go through the ceiling, and then also things like dryer vent holes. Anywhere there's a crack in your home, that is just letting the conditioned air escape from your house. So it's really important to seal those up along with doing insulation. Here's a picture from a Home Energy Squad energy audit. On the left is the picture, and on the right, the purple areas are where air leaks are happening. So you can see the attic hatch is super leaky, where the wall meets the ceiling is leaking. Even this wooden paneling has leaks in between it, and then the window too. And in an old house that hasn't been air sealed, all of the little cracks can add up to a 2 by 2 foot hole, which is like having a window open all winter long. So sealing those up is really powerful. As I mentioned, weatherization is really important for electrifying your heating system. And that's because it reduces the heating load required in your house. And the heating load is just simply how much heat energy is required to keep your home at a comfortable temperature. The cooling load is just the opposite. How much cooling do you need in the summertime? So when we're talking about weatherization, we're talking about bringing that heating load down so then the heating system doesn't have to work as hard. Another big thing that I'm sure a lot of you have been hearing about is all of the new rebates and incentives that are now available that weren't available even 2 years ago. So all this information is on our website. Don't feel like you have to write it down, but these are the main buckets. So utility rebates up to $3,000 from CenterPoint or Xcel Energy. And then the federal funding as well is really big. So there's right now a $1,200 tax credit for insulation and air sealing. And then starting next year, when the Inflation Reduction Act rebates will go live, there'll be an additional $1,600 that is available to folks earning less than 150% of area median income. There are also some cities that have rebate matches. So if you live in those cities, you may be able to get more incentives. So we'll be sharing the incentives for each type of project we're talking today. And again, you can go on our website, click on the project you're interested in, scroll down to the resources section, click on details and links, and you'll find everything you need to know, including the links to the providers of these incentives. All right. Let's move on to heating. And again, any questions, throw them in the chat, please. So when we're talking about energy use in Minnesota homes, heating is by far the biggest item. So compared to the national average, 72% of our energy use in a typical Minnesota home goes towards heating. So when weatherization, insulation is really important for bringing down how much energy you need to heat it. And then electrifying is how you go from using fossil fuels to clean electricity to heat. So who here has heard of a heat pump? If your camera's on, feel free to raise your hand or give me a little thumbs up reaction if you'd like to. But if you've heard of a heat pump, we're going to be talking a lot about them. So heat pumps, very basically, I'm seeing a lot of thumbs up. Thanks, everyone. Heat pumps are basically advanced air conditioners that can also run in reverse. So in the summertime, it works just like an air conditioner. It removes heat from inside your home and moves it to the outside. And then in the winter time, it moves heat from the outside air and moves it into your home, even when it's really cold outside, which is why this technology is so powerful. Also, when we're talking about electrifying your space heating, it's really important that we focus on heat pumps. This is a really efficient technology because electric baseboard heating, the old style electric heating, that's literally just heating up a piece of metal with electricity. It's super energy inefficient. It leads to really high energy bills, and it uses about 3 times more energy than a heat pump does. So when we're talking about switching to electric, going with the efficient heat pump option is what makes the most sense cost-wise, and also for the environment to not use so much electricity. Another reason why air source heat pumps specifically are really powerful and a really good option for a lot of folks is they have a lower cost compared to systems like ground source or geothermal. And they're also really flexible, so they can fit in most homes. There are 2 main types of systems that I want everyone to be aware of. So one is ducted and the other is ductless. A ducted or central system would basically just replace your central air conditioner, and then the refrigerant moves the heat into the house, and then it uses the same air handler that your furnace uses. So if you have ducts in your house with a furnace, this is the type of system you would get. The other option is a ductless or a mini split system, which is for homes that do not have ductwork. So if say you have a boiler or electric baseboard heating, this would be likely the option that would fit in your home. So same thing, it's got the outdoor unit, and then it moves the heat through the refrigerant lines to these indoor, they're called mini split heads. And you can have 1 to multiple in your home to heat different parts of the home. So this is a great way to bring air conditioning to a home with a boiler that would have to be using window ACs. And it's also a really great way to heat your home with clean electricity. All right, now let's talk about the efficiency of cold climate heat pumps. I say cold climate heat pumps because now there are heat pumps that are designed to work in Minnesota's climate, but there are also less efficient heat pumps designed for like the southern United States. So when I'm talking about heat pumps, I'm talking about cold climate heat pumps. So heat pumps are amazing. They can pull heat out of really cold air. That said, they do get less efficient the colder it gets outside because there's less heat to pull out of the air. So what that means is here in Minnesota, when we've got those polar vortex days, it is required that you have a secondary heating system to supplement the heat pump. And I'll talk about the details of that. Another reason why we talk about the weatherization is that as it gets colder outside, a heat pump needs more energy to provide the same amount of heat to the home. So in an unweatherized home, a heat pump, one that doesn't have insulation or air sealing, a heat pump can provide heat to the home in mild weather. But a well-weatherized home that's been insulated and air sealed can provide heat to the home with the same heat pump in much colder temperatures. When we have that smaller heating load, it takes less energy to provide that heating. The good news is that even though, we get really focused on the polar vortex days, when you go outside and the inside of your nose freezes, the vast majority of the winter, we spend above 20 degrees in Minnesota, in the Twin Cities area. So, and above 20 degrees, heat pumps are super efficient and they work really well. So the vast majority of the year, your heat pump is delivering efficient heat to your home. And then in that 20% of the time, that's in this below 20 degrees Fahrenheit, that's when we're going to start talking about the secondary system that you'll need. So there's two kinds of setups for secondary systems. One is what we call dual fuel. This is where you have an electric heat pump that is paired with a gas secondary system like a furnace or a boiler. And then the other option is all electric. So you have a heat pump and then electric resistance as that secondary. And I'll explain the details of both of those. So starting with dual fuel systems, this is a heat pump paired with a fossil fuel system like a furnace or a boiler. And the benefits are that it can keep your heating bills low because you can choose, depending on the different rates between gas and electric, whether you're using gas or electric. So you can keep your bills the lowest this way because you have that choice. And then it still comes with significant emissions reductions because, like I said, about 80% of the time, your heat pump will be heating the home. So basically, it provides cooling all summer and then heating for part of the winter. And then below a certain temperature outside, the heat pump will turn off and the fossil fuel system will take over. So just to quickly exemplify that, summer, your heat pump's cooling your house just like your air conditioner would. Fall, heat pump is doing all the heating. Winter, your heat pump is heating the home most of the time, and then below the 20-degree mark or whatever you set it to, maybe that's 30 degrees, whatever you like, your furnace or your boiler kicks in. And then again in spring, your heat pump's doing all the heating. So the pros of this are significant decarbonization. You're reducing your emissions by using the electric heat pump. And you have more control over the cost of heating. This is the way to get the lowest energy bills. One of the cons is it can be a little bit more expensive or it's not expensive, a little more complicated to set up this system because the gas system needs to be communicating with the heat pump system. All right, the all-electric option is next. So this is where the heat pump just has a secondary electric resistance booster heat. So you would move the gas system completely. This is the way to completely electrify your heating and maximize your emissions reductions. And the way it works is the heat pump cools your home in the summer, fall, And then in the winter, the heat pump keeps running all the time, but on those really cold days below 0 degrees, the secondary system will kick in to provide that little bit of booster heat that you need to keep your home at the temperature you set it at. And then again, in the spring, the heat pump's doing all the heating. So the pros of an all-electric system are that they maximize your decarbonization. You can eliminate your emissions from heating, and they can be simpler to set up because it's just the heat pump with that simple electric resistance secondary. The main con with an all-electric system is that your winter heating bills will likely be more expensive. This is because, like I mentioned earlier, electric resistance is very inefficient, and electricity is a more expensive fuel than gas right now. So on those really cold days when the electric resistance needs to kick in, that'll drive up the bills a little bit. All right. And as I mentioned, cold climate heat pumps are the model and efficiency of heat pumps that will effectively heat a home in Minnesota. And these are just some of the ratings to look for when you're looking for a heat pump. Also, if you just tell your contractor, I want a cold climate heat pump that can heat my home, they'll know what you're talking about and make sure to offer models that can deliver that. All right. So there are some big incentives available for heat pumps. Up to $2,000 from the utilities, a $2,000 tax credit, and then next year when the IRA rebates come out, it'll be up to $8,000 for income qualified families, and the state is planning to match that as well. And some of the cities also have those rebates. So if you are above this 150% area median income threshold, all of the rebates and tax credits that are going to be available to you are available right now. But if you fall below this income threshold, it could be worth planning those into your project next year. All right. And I see the what is the life expectancy of a heat pump? Typically the same as other HVAC equipment, about 15 to 20 years. Okay, we're going to keep it moving. So we talked about weatherization and heating. Now we're going to talk about your appliances. So water heating, cooking, and clothes drying. All right, starting with water heating. So after space heating your home, water heating is usually the next biggest energy user in a home. So who here has heard of heat pump water heaters? Feel free to give me a thumbs up reaction again. Great. So heat pump water heaters are electric water heaters that are super energy efficient. They are about 3 times more energy efficient than a standard electric tank. And they're safer than gas because they don't have that exhaust system that can backdraft and leak back into your house. And the way they work, it's basically a heat pump, like I've just been talking about, strapped to the top of your water tank. So, the way it works is the heat pump on top pulls in air, removes the heat from the air, puts it into the water. There's also an electric resistance element inside if you need a little boost. And then from that, you get hot water out, and also a little bit of cooler, drier air is exhausted. So compared to an electric resistance water heater, that's like your traditional water heater that just has a metal rod that's heated up with electricity to heat the water. A heat pump the heat pump water heater has the heat pump element and that traditional resistance element as well. So heat pump water heaters are much more energy efficient, have much lower energy costs. And since they're pulling air, they do dehumidify a little bit, which can be a nice plus. They exhaust a little bit of cool air into the space that they're in. So typically a heat pump water heater will run 3 to 4 hours a day. During that time, the temperature might drop 1 to 2 degrees in the room. Usually people don't notice it unless it's like in a living space. So that's just one thing to know. And they do make a little bit of noise just because they have that fan on them. So it's, similar to a bath fan level of noise, a quiet bath fan. But really the exciting thing about a heat pump water heater is how much more efficient they are. So compared to a standard electric water heater, you could save $300 to $500 a year on your energy costs. So that would pay for itself very quickly. Standard gas water heaters, if you replace standard gas with a heat pump water heater, you can expect the energy costs to be about the same, or you might save up to $175 a year. And right now we're seeing heat pump quotes coming in around like $4,000 to $5,000, and I'll show you the rebates later. Right here. So yeah, 4,000 to 5,500, and Xcel Energy has up to $500 rebate, and then there's some significant tax credit, and then the IRA rebates as well. All right, so that's water heating. Again, heat pump water heaters are a much better option than a traditional electric resistance because you'll save so much on your energy bills. All right, so cooking. Induction ranges are the exciting new thing in the cooking world, and it's really not that new. So induction ranges transfer energy directly to the pan using electromagnetic currents. So instead of heating up the air around it like a gas stove would, or heating up a piece of metal that then heats the pan, this is directly heating the pan. So they boil water extremely quickly, and they heat up and cool down just as fast or faster than gas. So people like it for the control that they get cooking. Um, the cooktop doesn't heat up super hot because it's heating the pan directly. They're really easy to clean. And then the one important piece to note is that the cookware you're using needs to be magnetic. So cast iron, stainless steel, ceramic cookware is all compatible with induction. But aluminum and copper pots are not compatible. So sometimes you'll have to replace your cookware. So these are a great option for folks who really like the control they get with a gas stove but want to go electric. And then traditional electric ranges are also a good option here. So unlike water heaters and heating systems where the heat pump technology is really important to focus on, cooking is a relatively small amount of energy use. So going with the traditional electric option is a good option. There's a lot of different price points. They've been around for a long time, but they are a little less efficient, and they warm up slower and cool down slower than an induction stove. All right. Yeah, and induction stoves are roughly 20 to 40% more efficient than a traditional electric stove. So why are we talking about electrifying our cooking? The big thing here is health. Gas stoves release hazardous pollutants into the home, and since the kitchen is usually a gathering place, that's where we like to be. It's the center of a lot of homes. That's these stoves are just leaking those hazardous pollutants right into the spaces that we breathe in most. Gas stoves can even leak when they're turned off. And yeah, so they're just health concerns, and studies have found that children living in households with gas ranges are over 40% more likely to have asthma. So ventilation is really important, and electric cooking completely eliminates this health risk by not having any combustion gases. There are fewer incentives for cooking, but still some. So next year, when the IRA rebates come out, there will be up to $840 for an induction or a traditional electric range. All right. And then let's chat about clothes drying. There's two options here. The first one is a heat pump or a ventless clothes dryer. These clothes dryers use heat pump technology and they recirculate warm air around the clothes to draw the moisture out of them. Um, and because of this, they do not need venting. So these are really great for folks who want to move their dryer like into a closet or onto the main floor where they don't want to punch a hole in the wall to run the venting pipe. So they're very flexible in that way. They do need a hose to a drain to drain the water that they extract, or you can have a pan that it drains into. They're also gentler on clothes and they are super energy efficient. They they use about half as much energy as a traditional electric dryer. That said, traditional electric dryers are also a great option. They come in a lot of different price points, from very cheap to higher end. And these just use traditional electric resistance, heating up coils with electricity to dry the clothes. They do need to be vented to the outside, and they, like I said, use about twice as much energy as a heat pump dryer. All right. And then last but not least, there will be up to $840 in IRA rebates when those come out next year in 2025. Okay, so those were the main areas of the home. Weatherizing your home, electrifying the heating system, heat pump water heaters, induction and traditional electric cooking, and then heat pump and traditional electric clothes drying. Those are the areas in the home that typically use gas, and tackling those one by one is how you will electrify your home. That said, a lot of us live in older homes that may need some work to get ready to electrify. All right. So, common upgrades that are needed in older homes are an upgraded service panel or modern wiring. Um, Some homes built before like the 1940s may have knob and tube wiring, which can be a fire hazard and also likely need to be replaced to install more electric equipment in a home. And then the service panel is really what limits how many different electric appliances you can have in your home. So a common upgrade is going from like a 60 to 100 amp panel to a 200 amp panel if you want to fully electrify. That said, a lot of folks, if you're doing it step by step, you may not need a new panel if you want to, just start by installing a heat pump, for example, or start with a heat pump water heater. You may have enough space on the panel to do that. And one easy way to find out how many amps your current panel is on the master switch. Usually right on the edge there, it'll say how many amps it is. So 100 or 200 or 60. So those are common upgrades to ask an electrician about if you're getting quotes on different electric appliances. And the other piece of this is if you're replacing say a gas water heater with a heat pump water heater, you'll likely need to run 240 volt wiring to that location in your basement or whatever it is. And then you'll also need to cap the gas line that the old water heater was using. So in most places where there was a gas appliance previously, you'll need that 240 volt wiring as opposed to a basic 120 volt wiring because heat pump water heaters, electric stoves, and electric clothes dryers all usually require 240 volt service. Again, when you're getting quotes on these things, contractors will loop that into the cost and talk to you about the options. So electric panels can sometimes sneak up as like shoot, I didn't want to have to do that, or like that was a surprise cost because you get really focused on like the shiny heat pump or the shiny stove, and then the wiring is what's needed. So there are significant incentives available for this as well. So right now, there's just a $600 tax credit. But next year with the IRA rebates, there will be up to $4,000, and then the state is adding an additional $3,000 up to. And then there will also be money for wiring from the IRA. Okay, so now we're going to talk about the different resources that are available to help you electrify your home and tackle the first project that you want to tackle. Like I mentioned, we want to help you wherever you're at. So maybe you're just, taking stock of your house and how old are the appliances? What should I do first? Or maybe you really want to reduce your carbon emissions and you're like, I'm getting insulation and I'm getting a heat pump. Wherever you're at, we want to meet you there. And the first service we offer is the Electrify Everything Advisors. So they're available to everyone in Eden Prairie and in the Twin Cities to give them a call or email them with any questions you have, and they can help you out. So say you got 3 quotes on a heat pump from different contractors and you want help figuring out, like which model of heat pump is going to fit my home the best. They can help walk you through how to figure that out. Or maybe you want help making sure you're getting all the rebates that you're eligible for. They're experts in that too. And they can connect you with contractors, answer your questions. So really, any questions you have, recommend starting with the advisors. Another really great place to start is getting a home energy audit from the Home Energy Squad. Give me a thumbs up if you've had the Home Energy Squad out to your home. This is a great service that so what they do is they assess the installation and the air tightness of your home. They also do direct installs of LEDs, programmable thermostats, weather stripping, and you'll leave with a report of where to start. So, if your home needs insulation, that's where you should start. But maybe you're good there, but your furnace is really old. They'll tell you that, and you can help you start planning. So this is a great way to understand where should I start? Okay. And then another important piece is finding contractors that are experienced and eager to install these pieces of equipment in your home. It's always disappointing if you're really excited about something and you get a contractor into your home and they tell you like, oh no, that's a terrible idea. Why would you do that? So what we've done is created lists of contractor networks who have gone through trainings and are really experienced in installing these different types of equipment. So for heat pumps, there's the Minnesota Air Source Heat Pump Collaborative's Preferred Contractor Network. It's a mouthful. They have a lot of contractors in the Twin Cities that are very experienced at heat pump installs. And I'll put these links in the chat in a little bit. Insulation, the Home Energy Squad has a list of partner contractors that do really good work. So that's a great place to start. Also, in a Home Energy Squad visit, the auditor can write an insulation quote that these contractors will honor. So that can kind of save you time there. And then lastly, we created the Heat Pump Water Heater Installer Network that provides a list of installers of heat pump water heaters who are experienced and know what they're doing and can help talk you through all the options. So to summarize, if you aren't sure kind of where your home is at or where to get started, a Home Energy Squad visit is a great way to get that report of what are the best places to start. And then when you're ready to dive into a project or have specific questions, contact the Electrify Everything advisors, and they can help line up all the different details for that project. And last but not least, our website is a great resource for more information on these technologies, the costs and all of the incentives, and then all of the resources I mentioned. All right. With that, we're going to open it up to Q&A. So I'm going to start by answering a couple of the questions in the chat. Keep putting your questions in the chat as well, and then I'll also call on folks by hand. Okay. So, do I still need a furnace with a blower functioning to use a duct type heat pump? Yes, a ducted heat pump will use the same blower fan that your furnace does to push the heated or cooled air around your home. So, it's important to have a high efficiency blower fan that's compatible with a heat pump. Let's see here. Can you over insulate a home? That's a great question. Um, the short answer is you cannot over insulate a home as long as you have a good ventilation system. So when you insulate a home and seal up all the cracks, it means that the air in your home can't escape, which is great, but it also means all of the humidity from breathing, any pollutants that get in the house will stay in the house unless you have a ventilation system. So that can look like having a bathroom fan that runs slowly all the time and just pulls a little bit of air out to keep fresh air circulating. Another option is it's called a energy recovery ventilator or an ERV, and that hooks directly into your ductwork and is a really great ventilation system. So if you're really insulating your home well, adding a ventilation system is important. Yeah, and then Rod, thanks for sharing that there are 120-volt heat pump water heaters available. That is true and really exciting. So, as opposed to a regular heat pump water heater that requires 240-volt service, there are heat pump water heaters that can just plug into a wall outlet with 120 volts. The one thing to note there is they usually provide less hot water as quickly as a 240-volt option. So if you have a smaller family, 120-volt might be a great option. It would also save you some money. But if you have a bigger family, it may not be able to provide enough water fast enough. Okay, from Sally, do you have any recommendations for contractors, handyman that will do a small job of improving rim joist insulation? Yeah, that'd be great to reach out to the Electrify advisors. They can give you lists of folks. In general, a contractor will be hesitant to come out if the job is really small. So yeah, it is helpful to find, handyman type folks that can do rim joist insulation. That's insulating the gap between the foundation and the floor in your basement. So yeah, reach out to the advisors and they'll get you connected. And then yeah, I think that's where I'm gonna pause there and I'll get to the chat questions, but I see Akilan you have your hand up. What's your question? Okay, I'll keep going. Um, have you worked with condo owners who want to go electric? That is a great question. It's not quite as simple as a single family home. There's some more variables. So one question is, does your condo building have a central heating system, like a central boiler, or does each unit have its own heating system? If each unit has its own heating system, heat pumps can be a great option. If there's a central boiler, it can be a little bit harder, and then it would be a matter of kind of looking at it from a whole building picture. We have talked with condo owners about electrifying their appliances, though, like your stove or your dryer, or even your water heater if that's in your unit. You can tackle those just like a single family homeowner would. Yeah, and again, if you have specific questions about your building, please reach out to the Electrify advisors. Well, one question I love to ask everyone is, what's your first step that you're going to take to electrify part of your home? Is it a home energy squad visit? Are you ready to go on a specific technology? Yeah, throw in the chat. What's your next step to electrify your home? Awesome. I'm seeing a HES visit. Um, I'll be following up with an email with a link to HES Home Energy Squad. I'm seeing evaluation, stove, water heater are of interest. Yeah, so deciding which one to tackle first. Interested in a heat pump. That's great. Getting some quotes from one of the contractors could be a great place to start. Home Energy Squad visit. Been waiting for it to get cold. Um, Sarah, they get pretty busy when it gets cold. So if you want to schedule it now, you might they're scheduling out, like 2 to 3 weeks, I think. So now could be a great time and hopefully it gets cold soon. Yeah, I'm seeing the home assessment. Currently have a bid for re-insulating the attic using solar tubes to add light. Yeah, that's great, Laura. If you are interested in getting like a second set of eyes on that bid, you can send it to the Electrify advisors and they can let you know if it looks comprehensive to them. Um, Dana had a dual fuel stove, um, capped the gas and replaced it with full electric. That's awesome. Congrats, Dana. An HES visit, looking into a gas dryer and old furnace replacement. I'm seeing a gas cooktop replacement and also a 17-year-old air conditioner. That's great to start planning for replacing that instead of when it's an emergency situation. Induction stove. Mike just re-insulated the attic when they did the roof. That is awesome. Way to go. Oh, and you got a 1,300 rebate from Centerpoint. Woohoo! The rebates are real and people are getting them. Fantastic. Um, All right. And Marilyn is fully electric. Congratulations, Marilyn. And good to see you. Thanks for joining. All right. Um, well, thank you so much, everyone. I'm gonna stick on if you have any questions or you want to talk about your home, like feel free to come off mute and let's chat. Um, and I'll hang out until 7, but otherwise, have a great night and thanks so much for joining.
Well, if nobody else is asking a question, I like that question about how do you know if you're over insulated? And yeah, how do you know if you're over insulated or because we do not have a ventilation system.
Mm, so it depends how airtight your house is, right? So a really definitive way to know would be to get a home energy squad visit and they'll do the blower door test where they pull air out of the house and they can measure how airtight it is. So that'd be like the most scientific way to know. But another way to know is just if you feel like stale air is getting trapped in your home, so like odors, or if it feels really humid in your house, that can be a sign that isn't able to escape. And for retrofitting, the cheapest option is just replacing one of the bathroom fans with a continuously running bathroom fan, and that would alleviate any of the ventilation concerns.
Thank you.
Yeah. And then a temporary fix is just like run your bath fan for an extra hour every day. It's manual, but does the job too.